Hi students, okay, today you are learning the topic is partial differential equations reducible to standard forms. Okay, in the previous lecture we discussed some standard forms 1, 2, 3, 4. Okay, now there is a finding directly solution of the given standard forms. Now the given partial differential equation is not standard form. First of all, reducible to standard forms, then finding the solution of that equation. So here given two types. So here first type equation of the form f of x power m p comma y power n q is equal 0 or f of x power m p comma y power n q comma z is equal 0 where m n are constant. This is the equation of the form. This is not standard form. First of all, this is converted to the standard form, then finding the solution. Okay na? So how to convert it here? Yeah, see the solution. First case 1 where m n are constants here. Here two cases are given. M is not equal to 1 and n is not equal to 1. This is the first case. So in this case, how to finding the converted to the given equation. So in this one, substituting the given equation, capital X is equal to x power 1 minus m and capital Y is equal to y power 1 minus n. And when n is not equal to 1, then in the given equation substituting, this is the capital X, capital Y and so that is equal to now capital F is equal to dou z by dou capital X and capital Q is equal to dou z by capital Y. So that is equal to, but we know that small p is equal to dou z by dou x, small x, that is equal, which is can be right. So that is equal to dou z by dou capital X into d capital X by d small x, because d that is equal to dx dou x cancel here, remaining same dou z by dou x, which is small dou z by dou x, which is can be write in the separating. So dx by dx means capital X is a function of x, single variable, that is the ordinary derivative. Okay now, so that is equal to dou z by dou x into dou z by dou capital X and capital P and dx by d small x and differentiating x power 1 minus m is a differentiation, that is 1 minus m into x power minus m. Okay now, this is a small p. So that is equal, which is can be right, x power minus m right outside, x power m into small p is equal to 1 minus m into capital P. Okay, similarly we have to finding the small q. Small q is equal to dou z by dou y is equal to, which is can be right, dou z by dou capital Y into d capital Y by d small y, that is equal to dou z by dou capital Y is equal to capital Q and dy by dy is equal to differentiation, that is equal to here. So that is equal to here capital Q into 1 minus n y power minus n. Okay, we write outside y power minus n, that is equal to here y power n into q is equal to 1 minus n capital Q. The both values, the x power mp and y power n q, both substituting the given equation we getting. So now given equation reduced to standard form 1 or 2. So this is the standard form 1 again, and a function of f of p comma q, this is function of p comma q comma z, and a substituting x power mp and y power n q in the given equation, totally converted standard form 1 and 2. Again same procedure to finding the solution of the given equation. This is a case 1. Similarly case 2. So case 2 means where m is equal to 1 and n is equal to 1. Then substituting here, capital X is equal to log x and capital Y is equal to log y. So that is equal to same, let capital P is equal to dou z by dou capital X, capital Q is equal to dou z by dou capital Y, that is equal, similarly same P is equal to here, finding dx by dx means 1 by x, derivative of log x 1 by x, that is equal to xp is equal to capital P. Similarly q is equal to dou z by dou y, so that is equal to here dou z by dou capital Y into dy by dy is equal to q into 1 by y, that is equal to right outside yq is equal to capital Q. Okay, now both substituting in the given equation, the equation reducible to the standard form 1 or 2. This is two cases, and this is a type 1. Now finding the same continuation, that is method standard form 1 and 2. Okay, this is a procedure. See the example here. See the first example. Solve non-linear partial differential equation x square by p plus y square by q is equal to z. So there is a given equation. So which is can be write p right in numerator and q is also can be write in the numerator. That is equal, which is can be write x power minus 2 into p whole power minus 1, because the equation of the form x power m into p and p power must be 1 and y power n into q power 1, that is must be. So which is converted into that form. So x square into p power minus 1, which is can be write total value x power minus 2 into p whole power minus 1 plus y power minus 2 into q whole power minus 1, that is equal to z. So which is in the form f of x power m p comma y power n q comma z is equal to z. So now here where m is equal to, so x power n ikkada minus 2 and m is equal to minus 2, ikkada y power n minus 2, ante both m and n is not equal to 1 as. So now substituting capital X is equal to x power 1 minus m and m is equal to minus 2 kada, x power 1 plus 2 ante 3, x power 3, and capital Y is equal to y power 1 minus n, 1 plus 2 is equal to y cube. So that is equal to capital P is equal to dou z by dou capital X and capital Q is equal to dou z by dou capital Y. That is equal to small p is equal to same procedure, that is equal to dou z by dou x is equal to dou z by dou capital X into d capital X by x, that is equal to p into dx by dx means differentiation of x cube 3x square, you know. So that is equal x square right outside, x power minus 2 into small p is equal to 3p. So similarly q is equal to small q dou z by dou y is equal, which is can be right dou z by dou capital Y into dy by small dy. So q into, that is equal to here differentiation of, so that is equal to q into 3y square, y square right outside, y power minus 2 into q is equal to 3 capital Q. So both substituting, that is equal to x power minus 2 into small p is equal to 3p and y power minus 2 into small q is equal to 3 capital Q. Both values substituting in the given equation 1, that is equal to here. So from equation 1, 3p whole power minus 1 plus 3q whole power minus 1 is equal to z. So observing here, this is of standard form 2. Function of f of capital P comma capital Q comma z is equal to 0. This is a standard form 2. So what is the solution of standard form 2? Now substituting z is equal to f of u, tentative solution given. So let z is equal to f of u, where x is u is equal to capital X plus capital Y, because here capital P capital Q gada. So u is equal to assumption capital X plus a into capital Y. So a is a constant. So now assumption dou z by dou capital X and the differentiation of z. So z is a function of f of u gada. So now differentiating with respect to capital X, that is equal to dz by du into dou u by dou capital X, that is equal to capital P is equal to dz by du. Similarly dou z by dou y is equal to dz by du into dou u by dou y is equal to capital Q is equal to a dz by du. Substituting here in the given equation 2, from equation 2, 3 into dz by du whole power minus 1 plus 3a into dz by du whole power minus 1 is equal to z. So simplification is 3 is a common, that is 1 by 3, and also dz by du common, that is inverse means du by dz. Take the reverse, 1 plus 1 by a into du by dz is equal to z. Now variable separable method, that is equal to integration of z into dz is equal to 1 by 3, 1 plus 1 by a is a constant, integration of du, that is equal to z square by 2 is equal to 1 by 3 into 1 plus 1 by a u plus c. So now substituting u is equal to capital X, a, capital Y. So z square is equal to 2 by 3 into 1 plus 1 by a into capital X plus a, capital Y plus c. But capital X, capital Y also assumption, that is capital X is equal to small x cube, capital Y is equal to small y cube. That is equal to the required general solution is z square is equal to 2 by 3 into 1 plus 1 by a x cube plus a y cube plus c. So this is the required general solution of the given partial differential equation when converted to the standard form. Okay, now this is a type 1. Okay, see the next example. Solve nonlinear partial differential equation x square p square plus y square q square is equal to z square. So that is equal to here, yes, this is a given equation, so which is converted to the first two type 1 form, that is equal to x power m into p y power n q, that is equal, which is can be write xp whole square plus yq whole square is equal to z square. So it is in the form f of x power m p comma y power n q comma z is equal to 0. So where m is equal to here and x power, or x power 1, x power 1, here y power 1, and m is equal to 1, n is equal to 1. Okay, substituting here capital X is equal to log x and capital Y is equal to log y. Similarly same, let capital P is equal to dou z by dou capital X and capital Q is equal to dou z by dou capital Y. So therefore small p is equal to here, simplification is dou z by dou capital X into dx by d small x, that is equal to derivative of log x here, the derivative of log x 1 by x. So x right outside xp into capital P. Similarly q is equal to dou z by dou y is equal to dou z by dou capital Y into d capital Y by dy, that is equal to q into 1 by y. So yq, small yq is equal to capital Q. Substituting both values, small xp into capital P, small yq is equal to capital Q in the equation 1. From equation 1, p square plus q square is equal to z square. Observing here, this is a function of p, q, z. This is standard form 2. So this is standard form 2. Same assumption, z is equal to f of u, where u is equal to capital X plus ay. Again same continuation. So since dou z by dou capital X is equal to dz by du into dou u by dou capital X, that is equal to here p into dou u by dou x means 1 gada, dz by du, capital P is equal to dz by du and dou z by dou capital Y is equal to dz by du into dou u by dou y. Dou u by dou y is equal to a. So a into dz by du. Substituting equation 2, from equation 2 dz by du whole square plus a dz by du whole square is equal to z square. So now take the common here, dz by du whole square common, 1 plus a square is equal to z square. So simplification is dz by du is equal to right outside z by 1 plus a square here, ante square root on both sides. dz by du is equal to z by square root of 1 plus a square. Now variable separable method, integration of 1 by z dz is equal to 1 by square root of 1 plus a square into integration of du, that is equal to log z is equal to u by square root of 1 plus a square plus c. But u is equal to substituting capital X plus ay gada. That is just substituting here. So that is equal to log z is equal to capital X plus a capital Y by square root of 1 plus a square plus c. But capital X capital Y assumption. So capital X is equal to log X, capital Y is equal to log Y, small x small y. Substituting that, the required solution is log z is equal to 1 by square root of 1 plus a square log x plus a into log y plus c. So this is the required solution of the given equation. Okay, see the next example. So solve the given equation x square p square plus xpq is equal to z square. Okay, first of all, which is converted to the form x power m into p comma y power n q. Okay, na? So that is equal to, which is can be right. So x square p square can be right xp whole square plus xp kada and x into p q, but there is no y. So there is no y means y power 0. Y power 0 into q is equal to z square and so xp, but q coefficient there is no y. Y can be right y power 0 into q. So which is standard form, which is equal to, in this the form f of x power m p comma y power n q comma z is equal to 0. So now substituting here m is equal to value, m is equal to 1. Clearly m is equal to 1, x power 1 and n is equal to y power 0 kada, and n is equal to 0. N is equal to 0 is not equal to 1 and m is equal to 1, x power n is not equal to 1, y power and capital X is equal to log x, capital Y is equal to y power 1 minus n kada. చూడండి, m is equal to 1 కాబట్టి capital X is equal to log x తీసుకోవాలి. So n is not equal to 1 కాబట్టి capital Y is equal to y power 1 minus n and n is equal to 0 అంటే y. So similarly same procedure, capital P is equal to dou z by dou capital X and capital Q is equal to dou z by dou capital Y. So small p is equal to dou z by dou x. So that is equal to here dou z by dou x into dx by x is equal to p capital P into 1 by x, that is equal to xp, small xp is equal to capital P. Similarly q is equal, small q is equal to dou z by dou y is equal to dou z by dou capital Y into dy by dy is equal to q, because derivative of y 1 kada. So that is equal to y eliminate means y power 0. Y power 0 into q is equal to capital Q. So substituting in equation 1, from equation 1 xp is equal to capital P kada, and p square plus capital P into capital Q is equal to z square. So which is the standard form 2, function of p q z is equal to 0. Now substituting z is equal to f of u, where u is equal to capital X plus a capital Y. A is a constant. So now continuation same procedure. Now eliminating capital P and capital Q. Now finding differentiation of equation 2 with respect to x and y kada. So dou z by dou capital X is equal to dz by du into dou u by dou capital X is equal to capital P is equal to dz by du. So dou z by dou capital Y is equal to dz by du. Dou u by dou capital Y is equal to capital Q is equal to a into dz by du. Substituting in equation 2, from equation 2 dz by du whole square plus dz by du into a dz by du is equal to z square. So now take the common here, dz by du whole square common, 1 plus a into dz by du whole square is equal to z square. So now write outside dz by du is equal to 1 by so that is equal to, after simplification, square root on both sides, dz by du is equal to z by square root of 1 plus a. So now variable separable, So integration of 1 by z dz is equal to integration of 1 by square root of 1 plus a into du. So that is equal to integration is log z is equal to, so 1 by root of 1 plus a is a constant, integration of 1 with respect to u plus a. But u is equal to substituting capital X plus a capital Y. That is equal to log z is equal to x plus a capital Y by square root of 1 plus a plus c. But capital X capital Y is equal to, capital X is equal to log x, capital Y is equal to y. That is equal to substituting here. Therefore, the given solution is log z is equal to 1 by square root of 1 plus a into log x plus ay plus c. This is a required general solution. Okay, now this is a equation converted to the standard form after finding the solution. Okay, thank you. For more videos, please do subscribe my channel, like and share. Thank you.